The International Space Station, where we've maintained a continuous human presence for more than a quarter of a century, which when you pause and think about that, I mean, literally for more than 25 years now, we've kept astronauts alive continuously on the International Space Station, probably the most complicated orbiting laboratory you could ever imagine. And it's a proving ground there for testing out capabilities on our spacesuits, on Eclipse, the life support systems that keep astronauts alive. But the next step is to take that to the moon, where the astronauts are going to be able to work with, again, the lunar regolith, in situ resource manufacturing. You can make water, oxygen, hydrogen. You know, these are all going to be critical components, skills that we're going to need to have if we're going to undertake missions to Mars. Because I can tell you, in the not-too-distant future, if you have the capability to return astronauts to the surface of the moon, you're going to have the capability to send them to Mars. The hard part is, how do you bring them home? You're going to actually have to make your propellant there on Mars. That's why under President Trump's national space policy said, don't just return to the moon and build the moon base. Make the next giant leap investments, which is nuclear power and propulsion. That's going to be a critical capability to move mass efficiently to Mars. And then the power when you're on Mars to make propellant to come home. We're going to use the moon base to figure that all out. And I'll tell you, you don't have to wait long. We're going to start launching missions. These are small robotic landers and rovers. Starting in 2027, we're going to try and work up to an almost monthly cadence of uncrewed landings as we start building out the moon base infrastructure.